Triangles. Some more criteria for congruence of triangles. So we know that the equality of 3 angles of one triangle to 3 angles of the other is not enough for the congruence of those 2 triangles. What happens when we have the equality of 3 sides of one triangle to 3 sides of the other? SSS congruence rule. If 3 sides of one triangle are equal to the 3 sides of another triangle, then the 2 triangles are congruent. Do you remember what a right-angled triangle is? To see the congruence of such triangles, we have a special rule. RHS congruence rule. If in 2 right triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle, then the 2 triangles are congruent. Note that RHS stands for right angle hypotenuse side. Go to exercise 7.3 on page 128 and try to solve question 1 from the textbook. First, think about what you're going to do. Question 1. Triangle ABC and triangle DBC are 2 isosceles triangles on the same base BC, and vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, then show that 1. Triangle ABD is congruent to triangle ACD. 2. Triangle ABP is congruent to triangle ACP. 3. AP bisects angle A as well as angle D. 4. AP is the perpendicular bisector of BC. How to solve this? Given that triangle ABC and triangle DBC are isosceles on the same base BC. So we have AB is equal to AC by definition. Hence, angle ABC is equal to angle ACB. Angles opposite to equal sides. Also, we get BD is equal to CD as DBC is an isosceles triangle. And angle DBC is equal to angle DCB. So, we have 2 pairs of equal angles and equal sides in these 2 triangles. Have you observed? ABAC and BDCD form 2 sides of triangles ABD and ACD. And the third side AD is common to both of them. So, what do we have? 3 pairs of equal sides in 2 triangles. Does that remind you of something? Yes, SSS test of congruence. We have very well used the equal pairs of sides so far. Let's think of angles now. In the triangles ABP and ACP, there is one pair of equal angles, which is angle ABP is equal to angle ACP, due to isosceles triangles. But then again, we have a pair of equal sides. AB is equal to AC, and also a common side AP for both of these triangles. Are we done then? No, not yet. Why? Everything seems to be perfect. 2 pairs of equal sides and 1 pair of equal angles. The catch here is that the angle ABP is not included by the sides AB and AP in the triangle ABP. Oh, what to do then? We must find an angle which is included between 2 sides in both the triangles. This can be achieved once we set up the congruence between the earlier triangles ABD and ACD. Once they will be congruent, the corresponding angles in those triangles will automatically be equal. Remember CPCT. Similarly, once ABP and ACP will be congruent, their corresponding paths will also be equal. Now, do fair work. Question 1. Triangle ABC and triangle DBC are two isosceles triangles on the same base BC, and vertices A and D are on the same side of BC. If AD is extended to intersect BC at P, then show that 1. Triangle ABD is congruent to triangle ACD. 2. Triangle ABP is congruent to triangle ACP. 3. AP bisects angle A as well as angle D. 4. AP is the perpendicular bisector of BC. 1. In triangle ABD and triangle ACD, AB is equal to AC as ABC is an isosceles triangle. AD is equal to DA, common. BD is equal to CD as BDC is an isosceles triangle. Therefore, triangle ABD is congruent to triangle ACD by SSS congruence rule. Therefore, angle BAD is equal to angle CAD by CPCT. Let this be 1. Let's go to the next one. In triangle ABP and triangle ACP, AB is equal to AC as ABC is an isosceles triangle. Angle BAP is equal to angle CAP from 1. AP is equal to PA, common. Therefore, triangle ABP is congruent to triangle ACP by SAS congruence rule. Let's go to the third one. From 1, angle BAP is equal to angle CAP. This shows that AP bisects angle A. Also, in triangle BDP and triangle CDP, BD is equal to CD as BDC is an isosceles triangle. DP is equal to PD, which is given. BP is equal to CP. CPCT for triangle ABP and triangle ACP. Therefore, triangle BDP is congruent to triangle CDP by SSS congruence rule. Therefore, angle BDP is equal to angle CDP, CPCT. This shows that DP bisects angle D. As ADP all lie on the same line, AP bisects angle D. Let's go to the next one. From part 2 we have triangle ABP is congruent to triangle ACP. Angle APB is equal to angle APC, CPCT. But angle APB plus angle APC is equal to 180 degrees as it's a linear pair. Angle APB is equal to angle APC, which is equal to 90 degrees. Therefore, AP is perpendicular to BC. Also, BP is equal to CP, CPCT. Therefore, P bisects BC. Therefore, AP is the perpendicular bisector of BC. Done! Go to exercise 7.3 on page 128 and try to solve question 4 from the textbook. First, think about what you're going to do. Question 4. BE and CF are two equal altitudes of a triangle ABC. Using RHS congruence rule, prove that the triangle ABC is isosceles. Let us first draw a diagram based on the information. Given BE is equal to CF and BE is perpendicular to AC and CF is perpendicular to AB. We have to prove that AB is equal to AC. Here it is directly given which test of congruence is to be used. RHS means right angle hypotenuse side. So, our task is to spot an equal pair of right angles, hypotenuse and sides. Angles CFB and BEC are 90 degrees as BE and CF are equal altitudes, that is, perpendiculars from vertices B and C. So, the triangles BEC and CFB are right-angled and have a common hypotenuse BC. With this, we have enough machinery to establish the congruence. But the question asked is a bit different. To prove ABC is an isosceles triangle, we need to prove angle ABC is equal to angle ACB, that is, AB is equal to AC. How to prove this? Again, we will take the help of corresponding parts of these congruent triangles for our rescue. Now, do fair work. Let us first draw a diagram based on the information. Given BE is equal to CF and BE is perpendicular to AC, CF is perpendicular to AB. We have to prove AB is equal to AC. Consider the right-angled triangles BEC and CFB. We have BE is equal to CF as it is given. BC is equal to CB, common hypotenuse. Angle BEC is equal to angle CFB, both are 90 degrees. Therefore, triangle BEC is congruent to triangle CFB by RHS rule. Therefore, angle BCE is equal to angle CBF CPCT. That is, angle BCA is equal to angle CBA. Therefore, in triangle ABC, AB is equal to AC, sides opposite to equal angles. Hence, the triangle ABC is isosceles. Done! Go to exercise 7.3 on page 128 and try to solve question 5 from the textbook. First, think about what you are going to do. Question 5. ABC is an isosceles triangle with AB is equal to AC. Draw AP perpendicular to BC to show that angle B is equal to angle C. We first draw the diagram based on the given things. As you can see, the right angles formed due to the perpendicular AP on side BC, we can surely think of setting up RHS type of congruence in the right-angled triangles APB and APC. For that, we will need an equal pair of hypotenuse and sides. What is the hypotenuse here? It is AB for triangle APB and AC for triangle APC. Oh wait! AB and AC are already equal. ABC is isosceles. Great! And AP is the common side for both these triangles. Cool! Amazing! We can easily see the congruence now. But the question asked is a bit different. Again, we will take the help of the corresponding parts of these congruent triangles for our rescue. Now, do fair work. We first draw the diagram based on the given information. AP perpendicular to BC, which is given. Therefore, angle APB is equal to angle APC, which is equal to 90 degrees. In triangle ABP and triangle ACP, angle APB is equal to angle APC, right angles. AB is equal to AC, given. AP is equal to AP, common. Triangle ABP is congruent to triangle ACP by RHS test. Therefore, angle B is equal to angle C, CPCT. Done!
If you like our videos, do share them and subscribe to our channel. If you want awesome quizzes, write to us. Keep watching and keep learning with Walnut.